Hey guys, in this lesson we would understand how to apply the laws of logarithms. Laws of logarithms can be used to simplify the problems or it can be used to evaluate the problems. We'll do both kind of examples. So let's say we're asked to simplify this. Simplify means write it down in one logarithmic function form. Like here we have two terms of logarithms, log 5 and log 7. We can only simplify a logarithmic problem if we have the same basis. And we do not see any basis in either of the case. That means both have the base 10. So they both are same. So what we can do is just simply we would apply the laws of logarithms. There is a plus sign, bases are same. We would just multiply these numbers and we would get 5 times 7. That would give us log 35. If the question wants us to simplify, we would leave here. However, if the question wants us to simplify and evaluate, then what we have got from here is log 35. We would further solve this to find out the value of this. And how do we find out the value? We would first write on the base here. We know there is no base to be seen, so base is 10. And if it is base 10, what we have to do is just put it straight on the calculator according to the key. The key on the calculator could be log 10 base or log no base. Both cases you would get the same answer, and the answer in this case is 1.54. So if the question wants us to simplify, we would stop here. This would be the final answer. But if the question wants us to simplify and evaluate, we would go further and stop here. So the difference between simplifying and evaluating is that simplifying is to just leave it as a simple final one log term, and evaluating means further finding the answer for that log term. So from here we know if the question wants us to evaluate, we would have to simplify it no matter what. Therefore, we'll be taking up all the examples to evaluate the logarithmic problems. If we have to solve this, log to the base 6 of 54 plus log to the base 6 of 2 minus log to the base 6 of 3, we can see that the bases are all the same, so we can apply the laws of logarithms. For plus sign, we multiply the terms, and for minus sign, we divide the terms. So how do we write it down as one log term? Log to the base 6 of 54 multiplied by 2, because these two have a plus sign in between, divided by 3. And the final answer would be 3 times 18 is 54, 18 times 2 is 36. We would be left with log to the base 6 of 36. If we are asked to simplify, we would stop here. But if we are asked to evaluate it, then we would go further and we would find out what is the value of log to the base 6 of 36. We know this can be written as log to the base 6 of 6 to the power of 2. 2 can be taken out, so we would be left with 2 times log to the base 6 of 6. 2 times log to the base 6 of 6 is 1. So the final answer is 2. Example number 3 is we are given log to the base 5 of 5th root of 125. We can first write it as log to the base 5 of 125 to the power of 1 over 5. Then in order to solve this further, we need to make sure that this 5 and here we should have a base of 5. And we know 125 is nothing but 5 to the power of 3. So we write on 125 as 5 to the power of 3. There is already one more power there. We would multiply both the powers, and in simplified terms we would get 5 to the power of 3 over 5. Then we would apply the power rule, 3 over 5 multiplied by log to the base of 5, and this would give us a 1, and our final answer is 3 over 5. So next question is use the laws to express in terms of this. And what do we have to express? The question for that is log to the base of b square root of x to the power 5 y z to the power of 3. Now we have to write this problem in terms of this individual logarithmic term. How do we separate this into 3 terms is first we would just simplify it so that it makes us look easier. Log to the base b, we can write on x to the power 5, y, z to the power 3. The whole thing can be raised to the power of 1 over 2 because square root means power is 1 over 2. If we have third root, that means the power is 1 over 3. Next, what we would do is we would bring this power on each individual. Bring this power on each individual variable. So 5 over 2, y to the power of 1 over 2, z to the power of 3 over 2. Now we have log to the base of b, and there are 3 terms. There is no sign, means these are being multiplied. We know that log to the base b of m plus log to the base b of n is equal to log to the base b of mn. So if there is a product of two terms and we want to separate them out, this is how we separate them out, by putting a plus sign in between. Here is a product of three terms, so we can separate all of these three out by writing it as log to the base of x to the power of 5 over 2 plus log to the base of y to the power of 1 over 2 plus log to the base of b z to the power of 3 over 2. And finally we can write it as square root of x to the power of 5 log to the base b y square root plus log to the base b z square root cube. And this is how we separated it into three different terms with log to the base of b. Let's do this last problem for the sake of practice. We are supposed to find out the value of x. Now whenever we are given three terms, one on the one side of the equal to sign and there is more number of terms on the other side of the equal to sign, but we have the same base, our first goal is to bring the two terms that are on the same side of the equal to sign into one term. And how do we do this? Is by using laws of logarithms again. So how do we simplify it? We would take this back as a power of x, log to the base 2 of 5, and then we would write it as log to the base of 2, and there is a plus sign, base is same, we can multiply x squared and 5, we are left with 5x squared. And why are we doing this? Because we have x on both sides of the equal to sign, so we need to make sure that we try getting rid of log in order to make it look easier. So now we can get rid of log because we have only one log term on each side of the equal to sign. So we can cancel these log to the base of 2. We'll be left with x equal to 5x squared. This square and this x gets cancelled out. We are left with 5x equal to 1. Finally, we are left with x equal to 1 over 5. And this is our final answer for x.